Hi everybody, it's Mark Sage, Executive Director of the area, and I'm here with the latest area Fireside Chat. Our Fireside Chats are speaking to some of the industry leaders about the work that they're doing and how the kind of benefits and challenges they've been gaining and overcoming. So I'm really excited to introduce Jack Eliker from Rolls-Royce. Jack, welcome. Can you quickly introduce yourself and tell us about your role at Rolls-Royce?
Sure, thanks, Mark. Yeah, I'm Jack Eliker. The title that I carry is Advanced Visualization Lead, which is just a fancy way of saying I work in the augmented virtual reality world, right? So XR. And I'm responsible for all of those applications throughout our defense sector.
Perfect. That's brilliant. Well, Jack, let's get to it. 3 quick questions. The first one is, how is Rolls-Royce leveraging AR and XR technology to address industry challenges or enhance their operations?
Yeah, there's a wide range, right? So in some areas, we've advanced pretty far. So in making use of virtual reality in our design reviews and in making efficiency gains through that, we're pretty far along. When it starts talking more about the augmented reality side, it's a little bit lagging, but in small pockets, we've been able to make big gains. And of course, it's advancing further along. So for example, with the virtual reality, we currently, any new engine program that we have coming up, it's a part of the process. We'll go in and we'll take a look at that within the virtual space before anything is physically built. One of the first times we used it, we had a new engine program coming up, and we said, hey, we want to try this virtual reality thing out for design. And we asked the new program leads, hey, when you're ready to cut parts, can you send us the CAD? We want to put it in here and then have you guys make sure everything imports good, looks good. So they got through their typical review process, said, hey, we're ready to cut parts. Everything looks super. And we took it, we put it in the virtual reality. There were about 4 people there at the time. They went inside of the virtual reality, took a look around, and in that roughly 8-hour period, they found over $50,000 worth of non-feasible design.
Wow.
And they said, well, maybe we ought to take some more time and look at this. So over the week, next couple weeks, they popped in and took further time. And by the time things were finished, it was over $1 million worth of non-feasible design in terms of the costs for time, as well as the parts themselves that would have had to been redesigned or replaced. So, that's a pretty significant saving for a first go without the intention of saving it. So from there, it was pretty easy to move things forward and get it integrated with anything new. And I keep saying with anything new because of course, Rolls-Royce, we make jet engines, turbo machinery, and some of the engines, they have a really long lifespan. And so they've been around since the 50s, some of them. In the 50s, they didn't even have CAD. So it's a lot more of an effort to go and scan if that's the route you need to go in order to get it put into the virtual reality. So in our digital transformation, we say born digital with a lot of our new engines. And then as we're able to, then we can start working on some of those more legacy engines. Augmented reality is a pretty similar realm. Just about every time that we try or do anything with augmented reality, we see that typical savings that most people do in that 20-30% reduction in time to perform tasks, as well as significant reductions in quality escapes, usually around 99% right the first time they do something. So a wonderful example of that was we had some of our dynamics team, so the vibrations people, they were having to put little dots around the outside of our engines. And if you've looked at a jet engine, the outside of it, it's round, it's curved surface. And so to put something in a very specific spot takes a lot of effort. And so the purpose of this, they were doing a modal hammer test. So it's where you have a calibrated hammer and you whack something in a specific spot and you measure how that dynamic response is and determine whether or not your asset is suitable for design. So they needed to whack all these spots, and there were hundreds of these little dots, and they needed to go around this curved surface. So they were taking strings, measuring the distance they needed to based off the design, and then putting that string, kind of holding it on or pushing it down to try and get it on that curved surface to place these dots, right? It was a lot of effort. I said it took them about 2 to 4 days on a particular carcass, which is the outside part of an engine. We said, hey, we can just take your CSV, the list of points that you've got, and put it into augmented reality and just overlay it right on top of the engine, or in this case, a carcass. That took a little bit of time, like an hour, to bring all that in and import it on top of the CAD and apply it to some of the augmented reality software we're using and put it out there. I took a look at it, and on this part, the first time that they were doing it, they had some of these dots already on there. And so they were able to place all the dots and see that some of these dots that they had placed were not even in the right spots. They were off a little bit due to human error, right? And as you can imagine, a string and a measuring tape, right? So anyway, by the time it was done, again, just turned the statement from the team was it turned that 2 to 4 days worth of work into 2 to 4 hours worth of an effort. So that's kind of the typical savings we see in terms of using augmented or virtual reality in various aspects of the business. We try to apply things in a way that makes sense, and we look at the whole life cycle of our products with a focus, of course, upfront on the design, trying to get as much resolved as you can in the design, and then, of course, carrying it through into our kind of digital prototyping. Sometimes we'll need to put an augmented reality overlay to verify the design meets what's needed. We do have a lot of mashups sometimes between the new engines or new applications of an engine into a legacy asset or a legacy airframe or whatever it may be. And so when we do that, we may have the CAD for the engine, but not the CAD for what it's going into. And so when you're trying to match those to a virtual reality, it may not be sufficient. So then we'll put an augmented reality digital prototype. It's a lot quicker, cheaper than the typical plastic printouts you might see, especially when you're talking about something that's really long and potential to break. And then, as we move then into actually building it, and this is where I'd say we're in the process of applying more broadly in the manufacturing realm of using augmented reality to reduce the time. Where we see the biggest gains are those things that are pretty complex for the mind to imagine or very similar to something else. So you can imagine placing wires around an engine or tubes. Those are where we tend to see our biggest gains in the assembly area. Just even having the work instructions right there next to the person actually provides a lot of gains where their hands are free to do a job even. So they don't have to go up and down ladders to look at their documentation. They can do sign-offs where they're at, those sorts of things. When we go into supporting it in the service area, we provide virtual reality training to our customers or to our own people as needed. We also then supply them with an expert on their shoulder, someone that can take a look at what they're doing within the augmented reality space and provide live feedback. As you can imagine, someone's got a scratch on an engine. They say, hey, is this okay? What do I need to do about it? It's out of tolerance. Typically, they'll take a picture, send it on, lots of back and forth, asking questions, and then eventually they'll get a disposition, which may be something like blend it, which is kind of smooth it out with really fine Scotch-Brite. And then they, so with the augmented reality, they're able to get that live feedback and talk to each other. And then they can overlay and say, I want you to blend this area, and physically draw and say, this is there, they need to blend, and they can blend it live, and they can say, yep, that's right. So that sort of thing, again, provides a lot quicker communication. And for us, it's important that fleets be ready, especially in the defense world. So again, try to apply it across the life cycle. In some areas, we're a lot further along than others. In some areas, it's just one-off cases, but that's how we try and do it.
Jack, that's amazing. Absolutely amazing. Kind of a whole range of different use cases. And to be honest, you answered quite a few of my second question, which was around the kind of the benefits and advantages that you've gained, talking about the kind of money saved, the time saved, and things like that. So just wary of the kind of time. The last question really is about some of the challenges and hurdles that you've had to overcome and potentially still overcoming. Can you just touch on a few of those and maybe some tips to how you've done that?
Yeah, we've come a long way. So I've been doing this over 10 years. And about 10 years ago, I started proposing using this technology within Rolls-Royce. And in those 10 years, of course, the technology itself has moved quite a bit. And so 10 years ago, it was like I was working in a closet trying to hide from our IT organization so that they wouldn't take my computer that could handle all the stuff we were doing. Uh, and I first proposed it, someone was like, I don't quite get it, but what could you do with a certain amount of money? And I said, well, I could do a little bit. I can't do it all. So I took that little bit of money and produced a little something. And then came back and they said, hey, I get it a little bit, but I'm still not quite sure. What could you do with a little bit more money? Well, I could do a little more, right? And so that proceeded on until to the point where they were like, I get it. It makes sense. I can see the value. And so having to overcome, when you're just talking about it conceptually, and again, 10 years ago it was a little bit less common. I think Pokemon Go may have been out, but not quite, right?
Only just, yeah.
Yeah. So, it's trying to explain to people what it is that you're really talking about sometimes is difficult. This really is something that sells itself once it's seen. People can understand it once they see it. So again, trying to get people to first understand what it is you're talking about, then the value of it. That's, of course, your initial challenge. Then we have to worry about things like the IT organization, getting them to accept, integrate it in. And it was really convenient. At one point, I was with our CDIO, which is over our digital and IT kind of stuff. And I just happened to be with them at a conference showing some of the virtual reality to a STEM class. We made a connection, started talking, and she got it and decided to put a little bit of help in getting through some of these hurdles we were having. And so that helped significantly. That was quite, I'd say, a turning point in our progress with IT. To the point now we have virtual reality integrated onto our typical IT computers. And any engineer that needs to do design work can get a computer that's virtual reality capable. They can get a headset that's capable as well and do that work as they need. When it comes to augmented reality, there's even more struggles, right? Because your computing power that's available on most of the augmented reality devices, especially anything that's a headset, is very limited. The number of even available headsets, right? You've only got a couple that are really out there that you could even use in a manufacturing environment. So that provides some issues. Add on top of that, that our IT organization only wants Windows. Any device that's not Windows, right? And so you can see my pool of potential devices that I could integrate into Rolls-Royce get smaller and smaller as we start thinking about the limitations of what IT has been traditionally. Trying to help our organizations see the need to expand beyond what we've used in the past. That has been the real struggle, and a little bit harder hurdle, I'd say. Especially when you're one aspect, right? And you've got a big the IT people, they have huge demands, right? They've got all kinds of software, all kinds of bits of hardware that they have to keep up to date, keep secure, and manage. So it's a lot for them to do. So that's, I'd say, where we're at on the augmented reality side, is trying to get that integrated more fully, like we have with the virtual reality, and running into some of those hurdles with legacy, what IT's mindset is, and what's available out there in the market.
Brilliant, Jack. Very insightful. Things that I do hear with other organizations, but it's amazing kind of the progress you've made, and congratulations on really pushing the envelope when it comes to this technology. So thank you very much. Look forward to hearing much more from you, and we'll stop there if that's okay.
Yeah, sounds good. Thank you, Mark.